Have you ever asked ChatGPT something and it gave you an answer that sounded completely convincing, only for you to find out later it was completely wrong? It confidently gave you a perfect lie, and the weirdest part was that it did not even say, "I'm not sure," or "double check this." It just made something up and gave it to you. A lot of people think this is a bug or something that is going to be fixed in the near future. But unfortunately, this is a fix that is never going to arrive. According to OpenAI, this behavior isn't something engineers simply forgot to fix. It's built into how today's large language models work, and ongoing research suggests that this behavior can never be eliminated, either by dataset enhancements or architectural improvements. In this video, to look at how these models actually work so we can understand why this happens, how AI models actually generate answers, and what you should and shouldn't trust when using LLMs such as ChatGPT, Claude, Copilot, and the rest. To understand why this happens, we first need to understand how LLMs work. Imagine you gave someone a giant box containing almost everything ever written. Then you say to them, "Learn from all of this, but don't memorize it. Instead, learn every pattern you can find." Once you've learned those patterns, your only job is to predict what comes next in a sequence of words. That's essentially how today's AI models work. They don't think the way humans do, they don't remember facts like people, and they don't retrieve information the way search does. Whenever you send them a request, they are using patterns they learned during training to predict what text is most likely to come next in a sequence of words. In this process, the model follows these three steps. Step 1, tokenization. The model does not see words the way humans do. It breaks your text into smaller pieces called tokens. For instance, the word understanding might become two tokens, under and standing, but common short words like the might be a single token. Each token then gets converted into a long list of numbers called a vector, and this places the token inside a big mathematical space. This happens because computers can't really understand language, they only understand maths. In this space, words with similar meanings end up numerically close together. For example, king and queen would be near each other, but king and refrigerator would be far apart. The models run on what's called transformer architecture, which was introduced by researchers at Google. Before this, AI language models had to process text one word at a time. They couldn't look ahead or look back. But the transformer came and changed that by letting the model look at every word in a sentence at once. And this takes us into step 2, attention. This is the core of the transformer. So instead of reading from left to right, the model analyzes your entire request at once, weighing how every single token relates to every other token. Some relationships matter more than others, and attention helps the model decide which ones deserve the most focus. Take the phrase, "a bank by the river." When the model processes the token bank, the attention mechanism notices the token river is also present. That relationship shifts the mathematical meaning of bank away from financial institutions and toward a piece of land. The interesting thing about this process is that no human taught the model this rule. It discovered a pattern by analyzing billions of pages of human text. After all that processing, the model then generates a response, one token at a time. Every upcoming word depends on all the words before it. It doesn't know where the paragraph is headed, and it's not following some hidden script. It's just making the best next prediction over and over and over again. During that entire process, there is no point where the AI model stops and asks, "Wait, is this actually true?" It doesn't know when it's wrong or right. It simply predicts what text is most likely to come next. If the pattern points it towards something true, that's wonderful. But if the pattern points it towards something false, it can sound just as convincing because the process is the same in both cases. When this happens, the model is considered to be hallucinating. At first, it looks like a simple mistake, and you might assume it's something that engineers will eventually fix in the next update or version. But hallucinations aren't just bugs or technical glitches. They are a consequence of how these models work. OpenAI stated that language models hallucinate because standard training and evaluation procedures reward guessing over acknowledging uncertainty. So instead of answering, I don't know. Models answer with a guess because something is always better than nothing. A research paper, Hallucination is Inevitable, further proved mathematically that getting hallucinations all the way down to zero is not realistic. This issue is further worsened by reinforcement learning from human feedback, which is the process where humans rate AI answers. Researchers also showed that because human evaluators prefer answers written with high confidence, the models learn to sound authoritative regardless of whether the information is accurate. The idea was further formalized by a researcher who proved that there's a fundamental trade-off in how large language models work. His research showed that no AI performing meaningful reasoning can be perfectly truthful, remember every relevant piece of information, preserve all meaning, and satisfy every user request at the same time. It has to make compromises somewhere, and in many cases, that's factual accuracy. Even so, hallucinations can still be reduced. A separate study argued that even though hallucinations can never disappear completely, their frequency can be lowered. Older models often hallucinated in 15 to 20% of summarization tasks, but newer models like the Google Flash 2.0 have reduced that to just 0.7% on the same benchmark. The dangers of these hallucinations are not just theoretical. They carry severe real-world consequences. Lawyers in a lawsuit against an airline used ChatGPT to help prepare a document. The AI confidently generated fake legal cases, complete with case numbers, codes, citations that looked completely real. When the judge asked for the original decisions, it became clear they didn't even exist. The lawyers were sanctioned, turning the case into a warning about trusting AI models without verifying their answers. Here are 4 simple ways you can use AI without getting burned. Number 1, change what you trust and what you verify. Not everything AI models produce carries the same hallucination risk. For instance, if an AI model is working from a document you gave it, it's less likely to invent information than when it's trying to recall names, dates, or citations internally without a source. So match your verification effort to the actual risk of the output type. Number 2, notice the confidence signals. Just because an AI sounds certain doesn't mean it's right. In fact, MIT researchers found that models can confidently repeat the same incorrect answer, which led them to develop a metric called total uncertainty. So instead of trusting one model's consistency, it compares answers across similar models to better detect hallucinations. Number 3, use the right tools for fact-dependent work. If you're researching something important, use the regular research or AI tools that search the web and provide sources that you can easily check. Number 4, never treat an AI output as the sole source. This should now feel obvious rather than like advice, but AI is still a thinking tool. If you're doing something that affects your job, your health, or your finances, or even your reputation, don't let AI be your only source. When an AI model hallucinates, it's not trying to fool you. It's just doing what it was trained to do, predict the next piece of text. Sometimes the prediction is great, but sometimes it's wrong. And understanding how they work and how to work with it will help you get the best out of it. Comment below if you've ever been caught out by an AI hallucination. What was it about? And did you catch it yourself or did someone else catch it? I would really love to know. Thank you for watching and I'll see you in the next one.